Okay, so my research involves stable isotope labeling of bacteria for identification. It is actually in twofold. There is one stage where I have to identify bacteria from a population which are able to cause cholera, dysentery, and many other bacterial diseases which are normally waterborne. And then the other part is bioremediation processes. So there is a lot of wastewater that is produced from the mines. So I have to identify bacteria that can be able to diminish or degrade some toxic organic solvents from wastewater to protect the lives of plants and people at large. So there it goes. So that is just a symbol of labeling. I'm using C13 normal carbon, but with 13 isotope and nitrogen 15. So just to give you a bit of a background, I just got some part from the report from the World Health Organization, specifically the DFID, which says our research into the prevention of diarrhea diseases is a major cause of death in infants in the poorest countries, and it needs more initiative, which I'm actually doing. So just to give you a background, you look at the numbers of the people that are affected by poor drinking water and those that actually die. See, so 64% of the deaths are actually in children. From there, so my focus is rapid detection of bacteria, because the current methods, normally it takes about 14 days to tell that this is the type of bacteria which is causing cholera. But in the actual sense, people are dying back in the affected areas. So we need something that is sensitive, more rapid, so that at least within 2 hours or 3 hours, we can ascertain the cause of the diseases and prevent it. So I'm targeting the metabolic profiles of bacteria. So the biological molecules in bacteria is a very simple technique, very cheap, because I just have to look at the vibration of those molecules. So those bacteria that cause cholera can easily be identified, and those that can remediate phenol can also be identified easily. So this is just a simple experimental plan. I need to give bacteria like labeled glucose, C13, and ammonia or phenol, so that I can easily separate those bacteria that can consume phenol to those that cannot by comparing the spectra of normal bacteria without any labeling and bacteria with labels. So I can tell from the Raman spectra. And you can see different concentrations to try and mimic the environment in which they are found. So they compete for resources within the complex microbial system. So we need to tell how much of this labeled substrate is being taken by which type of bacteria. So just to give you an example of what I've done so far. So the first one signifies identification of bacteria. So that the spectra represent the biological molecules, the vibration of biological molecules on the surface of bacteria. So the first one is Bacillus cereus, Pseudomonas putida, and E. coli. So from there you can tell. And then the bottom one signifies remediation process. So you can see we have two types of spectra. One is 0% 13C, which is essentially 100% carbon-12, which is normal bacteria. And then after labeling, you can see the shifts in peaks. That is the basis of identification. So this is just PCA to separate the bacteria to show that that bacteria, those clusters belong to that type of bacteria. It's just an extra way of proving identity. And we can do it at a single cell level. So population at single cell level, we can go to the site which is affected and use
30 seconds.
Okay, use Raman tweezers to eject bacteria, which we can analyze very easily. And then in conclusion, these are the economic and social benefits. If we can identify rapidly, then it means we can put up early interventions to protect the lives of people. Apart from that, already our hospitals are overburdened financially. So if we can put up something that can give a quick diagnosis of disease. It means we are protecting the institutions financially. And then to influence water and wastewater management or environmental audits so that we prevent the lives before we actually lose them. And the SDGs, which actually are connected to my research, are access to good health, SDG 3, and access to clean water, SDG number 6. So, and the last point says bioremediation of toxic solvents in order to protect public health. So, thanks very much for your attention.